And I'm back. So we're doing histograms. Who's excited? I'm excited. Histograms, I think, are useful. They're just bar graphs, but all the bars are squished together. I know I showed you the last one, so I'll go through the notes, and then we'll just do the question. Video is super long, so feel free to, if it doesn't make sense, reach out. So first thing we're gonna do is you go to my FCC, go to Canvas, we go to Zoom. And we're in module 2. Well, it's basically all the first one. There's tons of stuff in here, so I hope you're staying on top of it. But we are up to 2.2. 2.2 is 5 through 8 and 12 and 15. That's it. Let's look at the book. You click my math lab and mastering. We open the my math lab. And sorry, I was grading some stuff. And you click Pearson eText, and then we're right here. So we're going to 2.2. Histograms are great. Hopefully I can make this as clear as possible. Histograms. Let's see what they give you. I think I'm just going to do the questions. It's a graph consisting of bars with equal width drawn adjacent, unless there are gaps in the data. And it represents quantitative. Remember, that's numerical numbers. And the vertical is the frequencies. I like it. Important use shows the distribution, will show the center, shows the spread and outliers. This is what's called right skewed. I know the data's on the left, but you'd save it by the tail. To the right, right skewed. This again is right skewed. This is the relative frequency, so you can see it's in percentages. Nothing crazy here. This is normal. Beautiful bell shape, and I know I showed that before. It's pretty even. These are all one peak. That's a peak. That's a peak. It's got one high point. This you can consider it one peak. All right, okay, so this is skewed to the right because the tail is here. That's skewed to the left. But what about this uniform distribution? Might as well teach you that, right? When does this happen? All right, so we're in 2.2. Best ideas to think about it. We got normal. Oh, that's an ugly normal. We got the tail is on the right, so it's right skewed. The tail is on the left, so we got left skewed. Then we got one that's just straight up boom. Okay. Since there's probability in this course, sorry, that's not a full straight line. So this usually happens with probabilities. So let's do just a dice, a regular dice. We're going to do 1 through 6. So 1, 2, 3, 4, 5. Sorry about that. Sometimes my pen is not my friend. Here's 5. And here is 6. Okay, so here we go. Now, we're going to have the probability of rolling a 1, a 2, a 3, a 4, a 5, and a 6. Rolling a 1 is a 1 out of 6 chance. We divide this. 6 can't go into 1. 6 can go into 10 one time. And 6 can go into 40 6 times. And it just repeats. Okay, so this is 0.16 or 16. If we want to add the percentage, we times it by 100, 16%. Okay, so that means if we're going 0, 20, 40, 60, 80, and 100%, right? The probabilities, we're going to be right here for the first one. Now, the chance of me rolling a 2 is going to be the same. It's always for probability. It's always what you want out of the total. So we got 6 chances. How many ones did we have? 1. I don't write a 2 here because there's only 1 2 here. So to roll a 2 is going to be the same amount, 16%. To roll a 3, how many 3s are there? It's still 1 out of 6 or 16%. To roll a 4, a 5, a 6. So all of these are what? 16.6%. If you want to round it up to 17%, that's fine. But this is a way to have a uniform distribution. I know, so exciting stuff. All right, hopefully that was useful. But that's when you get a straight line. Let's see what else we got in here. That's it? Is that really it? I think that's it. Okay, I guess we got to do the questions. I didn't think there'd be a lot. Just how to do it on all these things like Stat Crunch and stuff like that. All right, whatever. We get to do them. That was fast. I knew this one would be fast. There's not much in here. So I know I showed you how to make one on Excel. I guess I'll show you how to make one on StatCrunch. So I guess we'll do that. We'll do a StatCrunch one. Won't that be fun for us? All right, so here we go. Here are questions. And let's see which ones we have to do. 5 through 8, 12, and 15. So here's number 5. Interpreting histograms. Answer the questions by referring to the following mini-tab generated histogram, which depicts the weights of all quarters listed in data set. Referring to the following mini-tab created at 40 weights and histograms are actually given, which depicts the weights, okay, of all quarters listed in a data set for 40 corn weights B. Okay, so we have quarters. We've got none that are between 5.8 and 6.0. All right. So before we do this, I want to build this on StatCrunch for you. Why? I think it'll be helpful. So this is their little picture. Cool. So let's go to this Appendix B and get this coin weight. Whoa, that got big. All right, so let's get into it. Appendix B, we want the coin weights. Data set 40 is coin weights. Nice. I literally just searched for coin. Okay. Does it actually give this to us? Oh, well, this is annoying. It'll be hard for me to build that. I don't want to type them all. Complete data sets are available at triolastats.com. So let's see if I can actually get the numbers. So I can just oops, that's a video. Triolastat.com. Boom. Download data sets. Look at us go. So go to this one. So now I got them all. They're in downloads. And I said I'd build it on StatCrunch. We got them all right here. Cool. Okay, so to get to StatCrunch, just gonna student links. I guess I got to go to my lab and mastery. Here's StatCrunch. Cool. Oh, we got all the data sets. So we click this one, the data set should come up. So I guess we didn't have to download it. Data sets, and we want the coins. I always hit Control F because my eyes are bad. Here's our coin weights. We're going to click it. It should open in StatCrunch. Nice. And they want the quarters, right? This is what they want. So I'm going to go to graph and I'm going to go to histogram. And I'm gonna go to where we got the quarters. Is it pre or post? I honestly don't remember. So I gotta get out of here. Go back to 2-2 for histograms. And we're on the basic skills concepts. And we want to do coin weights. And what is it? It doesn't say which ones they are. So I guess I'm going to use both. I think that's what I'm going to. Okay, so we're going to do the old quarters and the new quarters. So I have to click shift and have it there. Where, that's fine. Group by, that's okay. We want a frequency one. We can do the bins. Let's see what their bins are. 5.5. Oh my God. Every time I like breathe on it. Sorry. So 5.5 to 6.4. That's what the bins are. Okay, so start with, it says optional. Or 5.5. Are they 0.5 each? Oh, they're 0.1 each. All right, so let's make them 0.1. Markers for mean, percentage counts. That's fine. I'm not really going to put in the labels, but let's just see. Let's compute this thing. Input width must be greater than 0. Oh, I put a comma instead of a point. Sorry about that. Here we go. Okay, they did them separate. So here are the pre-quarters, here are the post-quarters. That's how you build the frequency table. They have both in one. I'm sure I could change that, but yeah, if I drag them over, but this is how they did it. So that's how they built their frequency. I know, not too exciting. I like Excel better, but hey, we got all these extra fancy things. So let's do the questions. Hopefully that was fun for you. All right, so here we go. Dun, 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 dun. What is the approximate number of quarters depicted in the 3 bars farthest to the left? The approximate number. This has got to be 11 plus 20 plus 7. So 11 plus 20 plus 7. You're approximating here, so that's 8. We got about 38 on the left. Cool. All right. That was it. Yep. Oh my God. If I click this one more time. All right. 6. Give the approximate values of the class width and the lower and upper limits depicted in the bar farthest to the left. So this is the bar farthest to the left. So the width is, how far is this? So the width is just 0.1. We're just going from 5.5 to 5.6. So for number 6, the first part, they want the width. And we got 0.1 here. And they also want the lower and upper limits of the class of the bar. So the lower limit is 5.5, the upper limit is 5.6. So the lower is 5.5, the upper is 5.6. So that's the upper. What else do they want? Oh, that's it? Cool. All right, we get to go to 7. How would the shape of the histogram change if the vertical scale uses relative frequencies expressed in percentage instead of actual percentages? All right, so how would the histogram change? How would the shape of the histogram change? Well, if we use percentages, it's all going to be kind of smaller. So this is like we got 5, 10, 15, 20. It's all going to be about the same shape. It's just going to be lower because this is about 7 out of the total. So how many total things do we have? You can estimate that this is 7. Well, we did 38 on the left. We can do the right. So that's 5, 18. So the right is going to be 5, 18. What is that? 12 and 4. That's 9 plus 10, that's 19. 39 on the right. So what is 38 plus 39? 77. So each one of these would be out of 77. You'd actually see how close we were. How many of these do we have for the coins? The quarters. All right, so the quarters on the left, we have, how off was I? We got 40 and 40. So we have 80 altogether. Mine was 38, 39. I was pretty close to my estimation. So we had 40 and 40, which is cool. But basically, they would all be lower values because instead of 11 for the first one, it'd be 11 out of 77. So trying to bring up the calculator. 14%. The first one would be 14%. The next one would be 20. So we'd have to change the scale, but if it was on the same scale and change the percentages, everything would just be way smaller. This is 26%. But it'd be relatively the same. They're lower values because it's decimals, but it all looks the same. The shape would not change. So I'll move that. Shape is the same. All right, let's do another one. Sorry, this is like 2.1, which is okay. We're just here in histograms. And I think it's 8 is the last one. Okay. What is a reasonable explanation between the gap between the quarters and weights? And the group of quarters weighs between 6 and 6.4. Okay, what is reasonable for the gap between quarter weights between 5.5 and the group of quarters with weights 6? Okay, so basically these are different years. So in one year, all right, to make anything, like I don't care if it's a door frame or a nut and a bolt or whatever it is, you have to have what's like a margin of error. So it's probably between, so you always look at the middle term. So this is like 6.2 and this is 5.65. What do I mean by what I'm saying? So before a certain date, I don't remember what it was, but let's say this is like pre, and this is post 70s. Whenever they changed it, whenever they changed the quarter, right? They changed it at some point. They made it lighter. So pre-70s, the quarters were about 6.2 with a margin of error. So it could be either plus or minus 0.2. So that's it. So they could be a little bit heavier or a little bit lighter because we're talking really small weights. So it's between that. And now it's 5.65 with a margin of error. So plus or minus, what can we go? So we're basically from 0.565 to 5.8. So what do I mean by that? So if we take 5.8 and minus 5.65, because you always take the middle term with a plus or a minus of 0.15. So it looks like they made it more precise. They made like the difference is smaller. And they also made the coin lighter. Why'd they make it lighter? So it was easier to carry more quarters for people. That's probably the change. And it was probably cheaper to use less of the metal whenever they made this change. So you could say it saves money. It's cheaper to produce. Cheaper to produce. You could say it's easier to carry. All right. Another way that they write this, they do, here it is. The other way that they can write this, just so you know, another way that they can write this, these are called margin of errors. Another way that they could write the margin of error is 6.5 x 5.8, and then they could write 6.0 x 6.4, and then you could just have the plus or minus with the x such that it's plus or minus the 0.2, or the 1.15, whatever it is. But that's the difference, and that's probably the reason. I guess I'll do number 12, and then you could do 15 yourself. All right, use the frequency distribution from exercise 16 and 2-1 to discuss a histogram. Say the skew. All right, so I'll do 12. You can do the last one yourself. So we're getting to make a histogram from tornadoes. Ooh, okay, so exercise 16 and 2-1. All right, going back to 2-1. -1, let's find this exercise 16, and we're gonna make it happen. All right, here we go. Tornadoes. These are our values. We got zeros, ones, zeros, fours. I think I'm gonna make it on Excel. I know I got StatCrunch on here, but no, I said I was gonna make these on StatCrunch. I'm gonna make them on StatCrunch. So that's the plan. But on the next video, I'll use Excel. So here we go. Let's go to the StatCrunch. So we go in here. Just got to open it. I'm just going to open a new thing for StatCrunch. I don't want to visit one. I just want to get a new one. All right. So let's just go to Open StatCrunch. And we're just going to make this happen. All right. All right, so let's put them in. So this is the F scale intensities of hurricanes. So F scale, I'm just going to put in all the numbers and hopefully not make a mistake. So we got 0, 4, 0, 0, 1, 1, 1, 0, 0, 0, 1, 2, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, 0. Okay. All right, now to the bottom. 0, 1, 0, 0, 1, 0, 0, 1, 1, 1, 3, 0, 0, 0, 2, 0, 3, 0, 1, 1, 3, 0, 0, 2, 0, 3. Okay, how many zeros? 1, 2, 3, 1, 2. So it's 5. 1, 2, 3, 1, 2. So I got 45 here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 45. Sweet. That's right. I counted them. We got the same. We got everything. So basically all we have to do is make one of these things. So I'm going to go to graph, histogram, F scale. Do they have stuff for the bins? I'm going to look back at the question just to make sure. We're at 2-2, right? It doesn't say what the bin should start at. They don't say the width. So we'll just let them do it for us. We could make it our own, but that's fine. So let's just go to compute. Okay, tons at 0. They made the bins 0, 1, 2, 3, 4, which makes sense. Just that's how many there are. There's not a major range for this. It's not really a histogram because they're like, they should be pushed together, but I'll survive. So this one starts high, ends low. The tail's on the right. It's right skewed. We just did it. So that was not hard at all. It is right skewed. Ta-da. Cool. Good luck. Let me know if you need help with this stuff. I'm here. I'm here to help as usual. I'm going to make the third one. But I hope this was clear. If it wasn't, just reach out. Take it easy.